All right, so what is a wallet and how does it work? Well, that's exactly what I'm explaining in this lesson, and I'm going to do most of this through demonstration rather than trying to rely too much on slides or anything like that. So I'm going to demonstrate this with software. First and foremost, the MetaMask Ethereum wallet. So you can install this to follow along with me if you want to, or you can just watch this video. I think you're going to get a pretty good idea of what I'm explaining just by observing, okay? So if you want to install it, you're definitely going to need it later in the Capstone project, but you can just wait to install it then if you want to. You can go to the MetaMask page here in the Google Chrome Web Store. Just, click install. I've already got it installed, so it's telling me to remove it. But if you don't have it installed, you can search for MetaMask and then click install. And you'll see this Fox icon up in your right-hand corner of your browser here, okay? And then the second one is going to be the Ganache Personal Blockchain. So this is a point-and-click blockchain that I sometimes like to use for development. And the reason I want to use it for this video is because it makes it very easy to visualize different wallets, and so we can explain how accounts work. So if you want to install this, you can go to trufflesuite.com/Ganache and then just download for your respective operating system. And then once you've got Ganache running, it should look like this. And you can just click Quick Start. So what is a wallet? Because there's often confusion about this term whenever beginners start working with blockchain. So one really important thing to understand is that a wallet is not the same thing as an account. I often hear these words thrown around interchangeably: your wallet, your account, your address, okay? Here are some terms that I see thrown around quite often. Wallet being synonymous with address, that's not true. Wallet being synonymous with the account, that's not really true. And it's also not synonymous with your public key either. So these are all closely related, but they are not the same thing. So let's explain the differences. So here's an example of a real world Ethereum address. I've got this pulled up live on Etherscan. So this is a real address on the blockchain with their activity on it. And you can even see this word address here. It's properly labeled that this is an address. Now, a lot of times people will call this a wallet. They'll say, hey, send funds to my wallet, and they'll, give you an address that looks like this. But they really just mean is this address. So what's the difference between an address and a wallet? Well, really, a wallet is software that lets you manage your address. So MetaMask is an example of a wallet. It's a piece of software that runs on your computer that manages your account, and it can manage multiple accounts, which we'll talk about here in a minute. So now let's revisit how accounts work. So we can see examples of these here inside of Ganache. Okay, whenever I start this development blockchain, it gives me 10 accounts or addresses for free, and it's got credited with 100 fake ether. And here I can see the address for each account. All right, this 0x followed by this string of hex characters here. And then I can also see the private key. Now, we talked about public keys, private keys, account addresses in the cryptography section of this program. So make sure you go watch that if you haven't already. But just a quick refresher. So, whenever you connect to a blockchain, you have an account address and you are the user of the network, right? And this is like your username, and this is your, your address, and your private key is kind of like your password. And if you have the private key, then you can generate this account address. And just a quick refresher, we do that like this, okay? So basically you start with the private key, and then you go through a hashing function that outputs your public key. So you start with the private key, which is your password, and generates your username, which is your public key. And then you get to your address by taking your public key and hashing it and taking the last 20 bytes and adding 0x. So basically this turns into this. So it's a multi-step process, but the whole idea is that if you have this private key, then you can generate this public key. Now, I want to show you that that's true because MetaMask can generate this account address from this private key. So I'm going to demonstrate that. I can just go here and copy this. And again, you don't want to use this private key for your development purposes or to store any real money, because anytime someone sees a private key, it's considered compromised, okay? And you should never store any cryptocurrency in this account. But let's go ahead and copy this and then go inside MetaMask. I'm going to prove to you that all you need is a password in order to control an account. So I'll go in here and I will do import account, and I'll paste in this, click import, and then boom, it already has imported it and it understands how to interpret the count. So you can see the first characters are 0x9d4. And those are the exact same characters, 0x94, because it understands how the cryptographic hashing functions work to generate this, public key, or the derivation of the public key, the address, from the private key. Okay, so another thing to understand about MetaMask is that, it's a wallet, right? It's an app. A wallet is an app. A wallet is not an address, right? But it's an app that manages multiple addresses or accounts. So if you see, I can do my drop down here. I can switch between a bunch of different accounts. I can import multiple accounts, and I can do that a couple different ways. So I can sit here and copy and paste every single private key, okay, into MetaMask like this. I could copy and paste all of these. Or what I could do is just take this thing right here, which is called the mnemonic seed phrase, and I could copy this and set up my MetaMask with this mnemonic seed phrase, and it would automatically import all of these accounts, all 10 of these accounts in one go without having to implement each private key one by one. So that's because this is called a deterministic wallet, or sometimes called a hierarchical deterministic wallet, which essentially, instead of just having a private key that generates a public key, you can have this thing called a seed phrase, okay, that will be responsible for generating a key pair, a public key and a private key, not only just one, but multiple, okay? So essentially, you can see these words here. This is a 12-word mnemonic seed phrase. And one of the reasons for this is because it would be a lot easier for a human to either memorize these 12 words in order, okay, or to be able to input this into a computer if they were going to recover a wallet. So, this is really hard for humans to even read this and, verbally communicate this or even memorize it, right? This is really, really, really hard. But, if you practice enough, you could memorize this, right? Or at least you could click some buttons on a computer to recover your wallet. And so that's one advantage here, is this is human readable. Now, so it has the advantage of, essentially, if you want to just control one wallet, let's say, or excuse me, one account, I even made my own mistake. If you want to generate one account, let's say you wanted to have this, be the wallet that I did it again, the address that you always receive cryptocurrency to, and you wanted to make sure that you always had access to this, you could do one of two things. You could write this private key down and save it and store it forever, or you could write down this mnemonic seed phrase and store it forever. And you could do both, right? So if you have the private key for this account, you can always generate this account. And if you have the mnemonic seed phrase for this account, you can always generate this account. You need either one or the other. If you have both, even better. So another thing about this mnemonic seed phrase, because this is a hierarchical deterministic wallet, this seed phrase can generate this address, and also this address, and also this address, and also this address. So, and so on and so forth. So that's what the hierarchy part is. It's hierarchical. It continues birthing more and more addresses from the exact same seed phrase with each their own unique key pair, your account address and your private key. And so that's why if you go inside of MetaMask and you just click here and you just click, create account, it'll just keep creating accounts because your MetaMask wallet has a master seed phrase that you typically get whenever you set the wallet up, and they typically ask you to back that up and save it somewhere. Okay. And so every time you click that add account button, it's just going to keep generating new key pairs of public keys and private keys, or addresses, I should say, for your account, just like Truffle would if you had this mnemonic seed phrase. So, Truffle here is also a wallet because any software that can take in a private key and take in, a seed phrase like this, generate accounts, really is a wallet, even though you're not using it to click buttons and sign transactions. But that's what MetaMask is doing. That's what Truffle's doing. That's the relationship for the key pairs of public keys, private keys, and addresses. And that's where mnemonic seed phrases come into play. And so one more thing I want to note here is that this mnemonic seed phrase is also very sensitive information. So anybody who's watched this video, you should never use this mnemonic seed phrase for your development purposes or store any cryptocurrency, because anybody who's ever watched this, me included, not that I would, could take, funds from you. All right. So another thing is that, if you want to, you could set up your MetaMask account with this mnemonic seed phrase. Okay. Or you could also export the mnemonic seed phrase from MetaMask and start Ganache with it. You can do a new workspace and then tell it, the mnemonic seed phrase that you want to. Okay. And then you can basically just put in your own mnemonic here, and then you can always work with a blockchain with the mnemonic that you intend. So I'm not going to demonstrate on screen right now. I'll let you do that as an exercise, but just make sure that you are, being careful with your mnemonic seed phrases. One really quick piece of advice that I do is anything that I ever show in plain text on my screen, I never store real cryptocurrency inside of it. If I ever record a video, I never use that for real cryptocurrency for sure. But even for you, anytime you see something flash like this on your screen, it's pretty safe to say that it could be compromised. It's just a good general rule of practice. Never store these inside of a text file. Never store your real world private keys inside of a text file. Okay. Anything that I actually use to store real world cryptocurrency funds in, I never use that same wallet for development purposes. All right, so let's actually start using the wallet to see what it does. We've seen how we can import accounts, how we can save, accounts with our mnemonic seed phrase or with our private key. Okay, I've already imported this account into Ganache here. Okay, so what I'm going to do is show you the functions of the wallet. So the really most basic thing that you can do is send cryptocurrency around. So I'll demonstrate that right now. What I'm going to do is actually take this second account list here. I'm going to copy the address. So again, this is the address. And I'm just going to click, I'm going to connect to Ganache first, actually. So basically, I'm going to take this right here, and I'm going to connect to Ganache. And here I can see my wallet, my account in the list. And I can see that it's got 100, fake Ether inside of it. So don't get too excited. It's not worth anything. But what I want to do is demonstrate how you can send cryptocurrency with this wallet interface. So I'm going to copy this second account here. Okay, I'm just going to copy it, and I'm going to click send and paste in my account. So this is the second address. And when you're sending crypto, let's just send some Ethereum or Ether cryptocurrency. I'm just going to put in 1 ETH, okay? And then you specify the amount of cryptocurrency you want to send, and then the gas price and the gas limit. Again, we went over gas prices and gas limits, in the section on Ethereum. So definitely go check that out if you haven't already. But essentially, gas is just an abstract unit. It always costs 21,000 units of gas to send Ether around on the Ethereum network. And the gas price is just the price that you're willing to pay expressed in Gwei. So 20 Gwei, we could make this 100 Gwei if we wanted to, make it faster, it doesn't matter. So anyways, you specify the speed here, you click next. And then finally, in the previous sections when I talked about, you have to sign a transaction with your private key to authenticate that message is from you before it goes to the blockchain. That's what you're doing here. So when you click confirm inside your wallet, it's going to sign it, the transaction information, which is saying just take cryptocurrency out of my wallet and put it in this other wallet. And it's going to create a digital signature that's going to send that in to the blockchain that tells it that this is a valid transaction from your account because the wallet controls the private key. So that's the final step here. We'll click confirm. And we can watch this take place in real time. Boom, there we go. We can see that 99 Ether is here, and then that 101 Ether is here. So it correctly took, cryptocurrency out of this wallet and put it into this wallet. And I'm even making my own mistake. I've done it several times in this video, trying to correct myself. I even use the words interchangeably wallet and account, but they technically are different. So took 1 Ether out of this account, put it into this account. And you can see transaction count is 1 here. All right, now I want to show you how you can use wallets to interact with decentralized applications or dApps, and also, smart contracts. So basically, if you go look at a blockchain website like this, all right, this is Uniswap. It's one of the most popular decentralized applications on the Ethereum platform. This is a decentralized cryptocurrency exchange where you can swap tokens like a vending machine. Basically, you can tell what cryptocurrency you have and what cryptocurrency you want to receive. Okay, and you just click swap. This is a blockchain-powered website. It's a dApp. And, most modern web browsers don't support blockchain connectivity out of the box. That's what you need a wallet for. Okay, so if you want to turn your web browser into a blockchain browser, you need this wallet installed to do that, because in order to use the blockchain, you're a user of the entire network, but your private key is the password to that account, and you have to have an address to represent that user across the entire network, and that's what your wallet does. So it lets you connect to the blockchain. It lets you use blockchain-based websites and manage your identity here, and also authorize any transactions that come out of your account when you're using those applications. Okay, so that's why you'll see connectivity with MetaMask when you go to a website like Uniswap. So I'm going to demonstrate how that works, what the user experience is like with the blockchain application, and how your wallet authorizes your account to do transactions. So basically, here at Uniswap, I just want to swap cryptocurrencies. So I'm using it on the Kovan test network. If you want to try this, you can. You need some, test cryptocurrency in your account. But basically, what I'm going to do is take some Ether and swap it for a token. So in this case, the DAI stablecoin, just called DAI. Okay. And so I'm just going to do 0.01. So this is the token that I have in my wallet, Ether. You can see that here. And I'm going to get a brand new token called DAI here. And it's going to give me 92 DAI. And I'm going to click swap. Okay, it's going to give me the final confirmation from the application that I want to do this. Click confirm, and now you'll see MetaMask pop up. So this is the user experience that's typical whenever you're using decentralized applications, because the application you've told the application that you intend to make this transaction, but the final approval must happen at the wallet level. Okay, so your wallet is where you must finally click this confirmation to say, yes, I authorize this transaction. I want to sign it and I want to send it to the blockchain. And so you can see, here are the gas fees associated with that. All right, you could adjust these if you wanted to. I'm just going to leave the gas fees, regular. So I'm going to click confirm, which is the final step that authorizes the transaction to take the money out of my account and swap the tokens. And you'll wait for it to finish. And then boom. So you can go see the transaction on the Explorer just like this. And there you go. You can see the final information about this. You can see the account it came from, the transaction hash, and you can see, tokens were transferred in this case, the DAI stablecoin and wrapped Ether, and this changed hands. And so that's what you'll finally see to make sure that your transaction went through. You'll see this success message on the blockchain. So there's multiple steps involved. There's using the website, signing the transaction with your wallet, and then finally confirming that the transaction went through on the blockchain when you look at the public block explorer to see the transaction status here. All right, so that's an overview of wallets, what they are, how they work, and how you can use them. So that's all I got for this video, and I'll catch you in the next one.